Today we're finishing up Unit 5 by evaluating inverse trig expressions. But we have some algebra to review. First of all, what's a function? A relation with each input corresponding to only one output. Graphically, we say it is a function if it passes the vertical line test. That means that any vertical line that crosses the graph should only touch the graph at one point. No more than 1 point. So you see this intersect, but it is not intersecting more than once. So a parabola passes the vertical line test, but a circle, this line right here, has already failed the vertical line test because it's intersecting the circle twice. Some more algebra review. What's an inverse? F and g are inverses if and only if f of g of x is equal to x and g of f of x is equal to x. This is called composition of functions, where you would actually replace the variable with the entire other function and then vice versa to check to see if they are inverses. This phrase, if and only if, occurs often in math for theorems and rules, and often is abbreviated to be IFF, or I always write it in cursive because my professor always did that, so it's just kind of ingrained. But if you see IFF, that doesn't mean someone spelled if wrong. That means they're probably abbreviating if and only if. What does an inverse look like graphically speaking? I'm going to graph f of x equals x cubed. Plugging in 0, I get 0. Plugging in 1, I get 1. Plugging in 2, I get 8. Plugging in -1, I get -1. And plugging in -2, I get -8. So something down here. This is called the cubic function because it's x cubed. And this table that we just kind of did looks like, when we end up graphing the inverse of x cubed is cube root x. Now what does that look like? Now I'm going to plug in values that are easy to take the cube root of. That would be cube root of -1 is -1, 0, 1, and 2. What do you notice about the points? Oh, they're flipped. So for inverses, every xy point of the first function, its inverse function will have the point yx, literally having flipped each xy point. Now I'm going to graph the inverse. Inverses also graphically, visually, have reflective or symmetric properties. They are actually reflected over the line y equals x. So this positive diagonal line is what our inverse functions are symmetric or reflected over. Is y equals x squared a function? Let's graph it. Even though I don't need to make a table of values, I'm still going to, so that when I graph the inverse, I just have to flip the table. As I graph the inverse, I'm going to reflect the points I previously had. All the y's will become x's. All the x's will become y's. Let's go ahead and graph. Is its inverse a function? Well, let's check with the vertical line test. This blue graph, is it a function? No, it's failing on every single line, okay? It's failing the test a lot. So the blue is not a function. mathematicians said we would like a parabola to have an inverse that is a function. So why don't we restrict the graph to only the positive values, only this upper branch and not the one below. The inverse function is called square root x, and that's why when we graph square root x, if we were to plug in 4, we only graph positive 2 and not negative 2. Is y equals sine x a function? Let's graph it. In order to swap these points, I need the y-axis to look somewhat like the x-axis, as in where in the world is pi halves? Is it between 1 and 2? Is it between 0 and 1? Okay, so I'm going to put a little bit less than negative 3. That's going to be negative pi, right? Because pi is 3.14159, blah, blah, blah. And this one's going to be approximately pi, which just gives us a little bit of a scale. So since that's how the max and min of my y-axis, those are the only points that I'm going to reflect, basically from negative pi to pi. So I will write those as a table and then we'll reflect them. We need to know also for the x-axis where is negative 1 approximately and where is positive 1. Pi over 2 is about 1.57. So if we take about 2/3 of that, we'll get, the best estimate that we can for where pi halves would lie. Sorry, for where 1 would lie. These will represent 1 and negative 1. Let's graph. 0, negative pi. Negative 1, negative pi halves. I also just wrote in the pi halves and the negative pi halves so that we could see where that was. 0 gives me 0. 1 gives me positive pi halves. And 0 gives me pi. Is its inverse a function? This right here, vertical line test, is failing. No, the vertical line test fails. So technically, when we just reflect the points, it's not a function. In order to make the inverse of sine a function, we have to put restrictions on it, just like we did with the parabola. They said, what if we just don't show it going on and on and on forever? What if we just take a sliver, a piece of the sine function? So what if it doesn't go all the way up to there and it doesn't go all the way down to here? This right here is just a tiny sliver, and that is inverse sine right there. That is called inverse sine. Remember, the notation that we use for inverse is to the negative 1. That does not mean reciprocal, okay? That does not mean 1 over sine. This is just the notation for inverse. Y equals sine x. This is the little sliver that they took, and that's what they reflected. Okay, y equals tan x. They took one of the full branches of tangent and they reflected that, but only one of those kind of tangent waves. They did not do the second one. And then for cosine, they took, again, a piece of the cosine wave and reflected it over the line y equals x and created the following graphs with the following restrictions. The range is what's going to be most important to us to know if you can actually take the inverse sine of some number, some value. When I talk about inverse, you may see that these pictures have written it as arc sine, arc tan, and arc cosine. That is the same as inverse sine, but a lot of people were getting confused with the inverse notation of to the -1, and I mean, rightfully so. So some textbooks use arc sine. A lot of them still use sine to the -1. I'm going to use, it's not to the -1, it's sine inverse, but they use this notation that looks like that. So that's the notation we're going to use, but personally I prefer arc sine. When you're dealing with arc sine or arc tan, you have the same restrictions to your range. You can only choose angles that are between -π² and π². So when we look at our unit circle, we can only use this half of it. But not just this half, we can only use angles that are literally between -π² and π². So the first quadrant, we're good to go. π/6, π/4, π/3, and π/2. Those are definitely within the restrictions. Now down here we have -π/2. On your unit circle, it's written as 3π/2, but we have to stay within the range, okay? Theta has to be between -π² and π². So you may say, oh, this angle can be used. It's called 11π/6. Yes, this angle is 11π/6, but is 11π/6 within the restrictions? So I plug it in, 11π/6. Is that less than π²? No, it's definitely not. It's not less than π². So it's not within the restrictions. This angle is still allowed. It just has to be called by a different name. It has to be called by a name of an angle that is between these restrictions. So instead of calling it 11π/6, I'm going to, that was too big, clearly, so let's subtract 2π. Let's subtract a full circle, get a coterminal angle. 12π/6, that's -π/6. Okay, is -π/6 between -π² and π²? Yes, it is. So that's what we call this angle. -π/6, -π/4, -π/3. Because these are the restrictions of arcsine and arctangent. The restrictions for cosine tend to be a little easier for students to grasp because it's from 0 to pi. The interval that we're allowed to use is from 0 to pi, and those angles are written on your unit circle exactly as you see them. Let's actually do some practice problems now. Sine inverse of 1/2. This is basically asking us sine of some angle is equal to 1/2. So we need to find what is that angle. In all the other sections of this chapter, we got oftentimes multiple angles. Okay, but for inverse trig, you will never have more than one answer because the restrictions make sure that you only get one answer. Sine inverse of 1/2. Where is the y value 1/2? The y value is 1/2 at pi/6 and at 5 pi/6, but only one of those is between negative pi halves and pi halves, and that would be pi over 6. Continuing on. Sine, we're going to start with the parentheses first. Sine of 5 pi over 6. When they ask for sine, they're asking for the ratio, not the angle. When they ask for inverse sine, they're asking for the angle, not the ratio. Sine of 5 pi/6. The y value at 5 pi/6 is 1/2. Sine inverse of that result. What angle of sine gives me 1/2? Hey, we did that in number 1. That's pi/6. Sine of negative pi/6. Remember, negative pi/6 is the same as 11 pi/6. The y value at 11 pi/6 is negative 1/2. Now I need to find sine inverse of negative 1/2. Well, sine inverse of 1/2 is positive pi over 6. That must be negative pi over 6. Hey, so you're telling me that if I take the sine inverse of the sine of an angle that is within the restrictions, it's just going to be that angle? Yes, but only if this angle is within the restrictions. So notice how this number 2 did not turn out to be 5 pi/6 as the answer, even though a sine inverse of sine can reduce. But 5 pi/6 is not in the restrictions for sine inverse. So since you're taking sine inverse of it, you have to choose an angle within the restrictions. But because negative pi/6 was within the restrictions, it ended up giving you the same thing. It was like asking, what's the square root of 4? And you say 2, and then what's 2 squared? Oh, that's 4. You basically undid and then redid the same thing. Sine inverse of negative root 2 over 2. The y value is negative root 2 over 2 at 7 pi/4 and 5 pi/4, but only one of those, well, neither of those technically are within the restrictions. But 7 pi/4 is in the area that I know that sine is in. So what is the angle that is within the restrictions for 7 pi/4? What other name can we call it? We can call 7 pi/4 as negative pi/4. And now we're going to find tangent of negative pi/4. I know that negative pi/4 is the same as 7 pi/4. So I go to the y over x, to the tangent value. That's negative 1. When they're asking for inverse, they want to know the angle. When they're asking for regular trig, they want to know the ratio. Cosine inverse of root 3 over 2. Where is the x value root 3 over 2? That would be at pi/6 and at 11 pi/6. But remember, cosine has different restrictions. The restrictions for cosine are between 0 and pi. So only one of those is satisfactory. That would be pi over 6. First of all, they said sine of 7 pi over 6. So they want a ratio first and then the angle. Sine of 7 pi over 6. We're looking for the y value at 7 pi over 6. That's the x value. Negative 1/2. Cosine inverse of negative 1/2. We're looking for the x value to be -1/2, and we're trying to find the angle. Is that 2 pi thirds and 4 pi thirds. But only one of those angles is within the restrictions for cosine. Cosine's restrictions are this upper half, so 2 pi thirds. Cosine inverse of -2. -2? I don't see that on my unit circle. -2 right here is an input for my inverse cosine. Okay, domain is what corresponds with the inputs. Is it allowed for me to even input -2 into the cosine inverse function? Is -2 in the domain of cosine, inverse cosine? I look here and I see that the domain of inverse cosine is -1 to 1. -2 is not even there. So this is undefined. There's no value there. I see this pattern again, this cosine inverse of a cosine. So what I'm going to predict is that my remaining answer will just simply be pi fourths. Let's see. Cosine of pi fourths is the x value, which is √2 over 2. Cosine inverse of √2 over 2 would be, that would be the pi fourths angle or the 7 pi fourths angle. Only one of those is within the restrictions of cosine, and that would be pi fourths. Hey, we were right, because pi fourths is already between 0 and pi, the restrictions for the range of inverse cosine. Where is the tangent value equal to 1? At pi fourths and at 5 pi fourths, but only one of those is between -pi halves and pi halves, and that would be pi fourths. Tangent inverse of -√3. Where is tangent -√3? At 2 pi thirds and at 5 pi thirds. Those angles by those names are technically not in the range of tangent inverse. But one of them is in the area. We just need to call it by a name of an angle coterminal to it that is in the restrictions of tangent. So 5 pi thirds, how do we call that? -pi thirds. Final one, sine inverse of 1/2. You did this twice in numbers 1 and 2. That would be pi sixth. Tangent of pi 6. Are they asking for an angle or are they asking for a ratio? They're asking for a ratio because this is regular tangent. It's not arctangent. Tangent of pi 6, the y value, is positive √3 over 3.